Section 4.6, Part B, graphing the rest of our trig functions. So all we have left is tangent and cotangent to graph. So for tangent, we're going to use a table, and we're going to think about that unit circle. So if you imagine the unit circle. For tangent, and we're really going to talk about this more when we start doing arc trig. For tangent, we're going to start at negative pi over 2, and we're going to go up until positive pi over 2, and we're going to go this direction and look at the values. So this value, negative pi over 2, when you do tangent there, that's 0, negative 1. Tangent is y over x, and that gives you undefined. Then as you work your way around, right in the middle, that would have matching x and y values, but it would be going downhill, so negative. So that's the negative pi over 4 is negative 1. Right at 0, tangent is y over x. So 0 divided by 1 is how you get 0, 0 there. Right in the middle here is positive y. Remember, tangent is the slope of all these lines as you go around until you get all the way back up to the top at pi over 2. You end up with 1 over 0, which is undefined again. So this represents one period of tangent, because after that it just keeps repeating over and over again. So if you look at our graph, we have the first asymptote that would be a dotted line, at negative pi over 2. And then the second asymptote at positive pi over 2. Right in the middle, which is going to be on the midline. And I was making that green, I believe, in previous videos. Right on the midline, it's on the x-axis, so 0, 0. And then at negative pi over 4, it's negative 1. Positive pi over 4, it's 1. And it kind of looks like a cubic. We still call that point an inflection point in the middle. You kind of make a graph like a cubic. Notice that the period is only the distance between two asymptotes, because then it just keeps repeating. And for tangent with no transformations, it's pi, which is why down here, when you start transforming it, it's pi divided by b. So instead of 2 pi, it's 1 pi divided by b. Then we're going to look at the cotangent, and we're going to do the same thing, the rip it and flip it idea. So if you look at the ones, if yours is in color, in black, this was your asymptote. This was your other asymptote. These were your points. And then it kind of repeats. Colors won't make sense again, but here's another asymptote. Here's your other points. And then that green line. So same idea. What was undefined becomes 0. What was 0 becomes undefined. So you rip it at where the black graph crosses the x-axis. So I'm going to switch to some crazy color so you can definitely see this. I'm going to rip it here where that dot hit the green line and where this dot hits the green line. And then where the blue asymptote, where your asymptote hits the green line, the midline, that was undefined. When you flip undefined, you get 0. So that becomes a point. So there's a point right there. And then your other 2 points stay points. And then this curve is the cotangent. We use the other 2 points. We rip it up the asymptotes. Okay, so some of the things we're going to have to do is decide if it's even, odd, neither, and all that other stuff. So let's make some lists. This is for both tangent and cotangent. There's no amplitude, so more than likely we won't ask you for amplitude. There's no relative min or max, because this is just going up and down forever. There's no bottom of a valley, top of a hill. It's when we do even, odd, neither, it can never be even. Right? For even, it has to have a min or a max at the y-axis. And since there's no min or max, you can never fold this on the y-axis and have it land on itself. If it's going to be odd, it can't have a vertical shift. As soon as that d value is plus or minus whatever number, it can't be odd. Because if it was up and you flip it over, now it's down. And if it was down and you flip it over, now it's up. The other restrictions are it needs to either have an asymptote through 0, 0, or on y-axis, or the inflection point at 0, 0. If these things aren't the case, then it's going to be neither. It'll never be even. Okay, let's do our first example. So I am going to set up the normal answer blanks that we would have that you could do like before you start graphing it. So those would be vertical transformation. I'm going to pause this and just write these down. Okay, there you go. They were also at the top, right? Vertical transformation, vertical reflection, period, phase shift, vertical shift. Let's just start answering this. So this is a tangent graph, so we don't need to do the rip it or flip it part. Vertical transformation comes from the number in the very front, right? There's a 2 in the very front. That answers these two questions. 2 means stretched vertically by 2 if you want. The 2 is not negative, so there is no vertical reflection. Then we have the b value is the imaginary 1 right there. 2 pi, nope, this is tangent. Pi divided by b, which is just 1. So the period is going to be pi. Phase shift comes from inside the parentheses. It says minus pi, but you actually move it the opposite way, so write pi. And vertical shift comes from the number at the end, plus 1. As soon as I see that, so first of all, it's up 1. As soon as I see that, I know it can't be odd. So now we know this one's neither. Let's just write that down. We'll talk about it later, but even, odd, neither. Odd. We said tangents never even. And then as soon as you have a vertical shift, you know it's neither. Okay, so our table for tangent. You're welcome to make your table bigger if necessary, but I'm not going to show every single step along the way. There we go. Tangent theta. Remember, it starts at negative pi over 2, and it goes counterclockwise like it's supposed to. Negative pi over 4. Then you're at 0. Then you're back at positive pi over 4. Then pi over 2. It starts undefined. Then it's negative 1. 1. Sorry, 0. 1. Undefined. So x over b plus c. X over b plus c, ay plus d, like before. I mixed some lowercase and capitals in there for some reason. So x divided by 1, and then plus pi, because it's opposite. And then a 2y plus 1, because it stays the same. So this is the part I'm going to start doing in my head now. So pi, when I'm doing a common denominator of 2, that's really 2 pi over 2. So negative 1 plus 2 is pi, and then over 2. Undefined times 2 and plus 1 stays undefined. Negative pi over 4, so I need a common denominator of 4. So plus 4 is 3 pi over 4. Negative 1 times 2 plus 1. Negative 1. 0 plus pi. 0 times 2 plus 1. 1/4 plus 4/4 is 5/4. 2 plus 1 is 3. 1/2 plus 2/2 is 3/2. Undefined with any math is undefined. So it might be helpful to write these in common denominator form. I don't have a lot of space, so I'm just going to write them down here in parentheses. If I look at these denominators, 4s are in them. So this is 2 pi over 4, just the x value. This is already 3 pi over 4. That's 4 pi over 4. That's 5 pi over 4. And you can see what's happening here. And remember, the x's always have that nice common distance between them, so that helps me know that we did do this right. Okay, so over 4s, my y's go down to negative 1 and up to 3. My x's are all positive, so maybe here. It does go down to negative 1, but it goes up to 3, so maybe here. Label your axes. We're counting by fourths, so pi over 4, 2 pi over 4, 3, 4, 5, 6. We'll go all the way out to 7, just so I can see it. Y-axis is common to go by 1s, but write it down. Okay, so now let's plot our points. At pi over 2, or 2 pi over 4, It is undefined, so that's your asymptote. 2 tick marks, 2 pi over 4 is undefined. At 3 pi over 4, it's negative 1. My third tick mark is negative 1. At pi, my fourth tick mark is positive 1. At 5 pi over 4, my fifth tick mark, it's 3. And at 6 pi over 4, it's another asymptote. Try to make it look kind of like a cubic. It's not a cubic, but it does have that same inflection point idea. And then we will answer all the questions for afterwards. Okay, so domain, range, asymptote, y-intercept. Remember, we already did even, odd, neither. You can see that there was a vertical shift. So if you flipped your paper upside down now, the inflection point right now is above the y-axis, but if you flip it upside down, it's going to be below, so that clearly is not the same thing. So asymptote first. My asymptote, my first undefined, I like to use the left one, you could use either one, is that x equals, it was pi over 2, but it repeats every period. Remember, the period answer up here for this one was pi. That wasn't the right color, but pi. So plus or minus pi n to say that it keeps repeating every period. So the domain is all real numbers except for those. X cannot equal pi over 2 plus or minus pi n. Range, this graph goes up and down forever, all real numbers. And y-intercept, you could either try to repeat your graph backwards to find it, but sometimes that's easier, sometimes that's harder. Or, remember, this is why we practice that unit circle. Here's my equation. I'm plugging in 0 for x. That's a negative pi. At negative pi, this is the point negative 1, 0. Tangent is y over x, so tangent of negative pi ends up being 0. So I get positive 1, so 0 comma positive 1 is the answer to my y-intercept. So this is our first graph. This is tangent. Okay, moving on to cotangent. We are going to start by pretending this says tangent. Also, I believe I changed this. Sorry. Make sure mine matches yours, or change yours to match mine, whatever it is. It's cotangent of 1/2 x plus pi minus 1. So what I'm saying is that should have been what the paper in front of you says. So when I change it to tangent, take out the 1/2, divide by 1/2. When you divide by 1/2, that's the same thing as multiplying by 2. This is the one I'm going to graph for tangent. And actually, I'm going to switch colors. I'm going to make this kind of a dark gray so you guys can see it. But I am going to graph tangent in dark gray because that's not going to be the final answer. The vertical transformations and reflections are all going to be the same though. So transformation, there's no a value, so none. There's no a value, so it's not negative. Period is pi divided by b, but we don't leave dividing by fractions. I literally just said dividing by a fraction is the same thing as multiplying by the reciprocal, or in this case multiplying by 2. So 2 pi is the period for this one. Phase shift, it says plus, that actually moves it left 2 pi. And vertical shift, it says minus 1, so that moves it down 1, which, just because I wrote that down, I might as well do even, odd, neither. Tangent and cotangent is never even, and the vertical shift means it can't be odd, so this one is neither. Okay, in a different color for me, we're going to do tangent theta, and then we will do what we need to do afterwards. So again, negative pi over 2, negative pi over 4, 0, positive pi over 4, pi over 2. Starts as undefined. Negative 1, 0, 1, undefined. X over b, x divided by 1/2 is 2x minus 2 pi, 1y minus 1. Maybe pause it and see if you can do some of these. So 2 times negative pi over 2, the 2's cross out, and you have negative pi minus pi is negative 3 pi. Undefined, any math stays undefined. Negative pi over 4 times 2 is negative 1/2, minus 4/2 is negative 5/2. Negative 1 minus 1 is negative 2. 0 minus 2 pi, negative 2 pi. If you want to do common denominators, this is common denominators. Negative 6 pi over 2. This is negative 5 pi over 2. This is negative 4 pi over 2. What's going to be next? Negative 3 pi over 2, and then negative 2 pi over 2. So if you want to trust your first few steps, then follow that pattern for your last couple. That reduces to negative pi. 0 minus 1, 1 minus 1, undefined stays undefined. Remember, this is tangent. So set up some axes that make sense. It's all in the negatives. So I'm going to leave some space over there. It's all in the negative x's. It's all in the negative y's. My common denominator in red is over 2. So negative pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2 is the last one that we need. 1, negative 1, negative 2, negative 3, negative 4. Okay. Plot what we have. At negative 3 pi over 2, or at negative 6, so 6 tick marks, it's undefined, asymptote. 5 tick marks, it's negative 2. 4 tick marks, it's negative 1. 3 tick marks out, it's 0. 2 tick marks out, it is undefined. Tangent kind of looks like a cubic. And then it is helpful to have another graph, another period of tangent for this. So if I just keep repeating that, 1 unit over, it was down at negative 2. 1 unit or tick mark over, it was at negative 1. 1 tick mark over, it was on the x-axis. 1 more tick mark, and it would be an asymptote. So this, do it light or do it dotted, is tangent. Okay, now we rip it and flip it. So the green line, the vertical shift, the midline, I'm going to use an actual pencil for you guys, sorry. Right through the inflection point of tangent. That's where everything happens. If it's on the green line, notice that you should have 2 of them. That was basically an answer of 0. When you flip 0, you get undefined. So those are your asymptotes. This is why we needed 2 periods, 2 pictures of tangent. Where it was an asymptote, so where your dotted lines cross, now becomes a 0, or an intercept on that midline, a point on that midline. And then the point right here is a point, and the point right here is a point. Looks like a cubic going downhill. This is our graph of cotangent. The red one is our graph of cotangent. Okay, there are my answer blanks for cotangent. Asymptotes, the far left one, it was 1, 2, 3, 4 tick marks to the left. So 4 over 2, which is negative 2 pi, x equals negative 2 pi, plus or minus. The period for tangent was 2 pi, n. So domain is all reals x cannot equal negative 2 pi plus or minus 2 pi n. Range goes up and down forever. And the y-intercept, remember I'm looking at the red one, it has an asymptote on the y-axis, so the y-intercept does not exist. Okay, this is tangent and cotangent. We will talk about it more in class, and I hope you guys are doing good.